Hello everyone. So in this video we will be discussing trigonometry. So trigonometry is a branch of mathematics that deals with the measurement of sides and angles of triangles and their relationship. So basically in this video we will be discussing more of the degrees, the radians, basically about the angles of a triangle. So first, we will be discussing the systems in measuring angles. So there are three types of measuring um, systems in measuring angles. The first one is the sexagesimal system. It has the degree as the fundamental unit. As you can see, we have here the symbol degrees, and the degree can be divided into minutes, which is denoted by a single quote, and seconds, which is denoted by this one. So the important conversions that we need to know or we need to remember is one revolution or one circular rotation that is equivalent to 360 degrees. So for example, if we have a Cartesian plane of this one, meaning to say one circular rotation of this one is equivalent to 360 degrees. But I know you already know that one from your previous mathematics subjects. And we also have 1 degree as equivalent to 60 minutes, which is equivalent to this one. We also have 1 minute is equivalent to 60 seconds, which also can be denoted as this one. So the next system of measuring angles is the circular or natural system, which has the radian as the fundamental unit. So important conversions that we need to know is one revolution or one circular rotation that is equivalent to 2 pi radians or 2 pi rad, and 1 rev is equivalent to 2 pi rad. And 2 pi rad or 2 pi radians is equivalent to 360 degrees, meaning to say again from a Cartesian plane, if we have the Cartesian plane as this one, meaning to say one circular rotation, one 360 degrees rotation is equivalent to 2 pi rad or 2 pi radians. Another one is the other trigonometric measurement systems, which is for the important conversions, we have one revolution is equivalent to 400 gradients, and one revolution or one circular rotation is equivalent to 6,400 mils. So basically, this is the conversions or equivalent conversions that you need to remember. So now we will be discussing example. We have here convert the angle from degrees to radians. So the first example is 135 degrees, and then we need to convert that one into radians. So again, we have here for the conversion given an angle 1 that is equivalent to 180 degrees all over pi rad. If you will be converting a radians to degrees, but since we are converting degrees to radians, so basically we'll need to use the reciprocal of this one, which is pi rad all over 180 degrees. So again, we need to multiply 135 degrees by this one, the pi rad. So we have pi rad divided by 180 degrees. So degrees can be cancelled from here. So basically we have 135 pi rad all over 180. So if you simplify that one, 135 divided by 180, that is 3/4 pi rad. This one can also be written as 3/4 pi, since automatically, if you don't write a degree sign, that is automatically understood as radian or rad. So basically, this is already the result of our conversion of 135 to radians. So we have 3/4 pi. Now we'll move on to another example. We have here negative 620 degrees, 5 minutes, and 51 seconds. Now, if you try to calculate this one in your calculators, this is already equivalent to 620.0975. So from here, this is already equivalent to the degrees. Since again, this is just the minutes and this is the seconds. So if you combine that one, that forms of 620.0975 degrees. And again, we are converting that one to radians, so we need to divide that by pi rad all over 180 degrees. So cancel the degree, cancel the degree. So we have negative 620.0975 multiplied by pi and divided by 180. So that is equivalent to negative 10.8227 rad. Or basically, you can just write that one in as 10 or negative 10.8227. So this is already our conversion of our degrees to our radians. Now let's move on to another example. So we have here, convert the angle from radians to degrees in 4 decimal places if possible. So again, since this is now radians to degrees, we will be using 180 degrees divided by pi rad now. So we have 11 over 6 pi rad. Just rewrite this one. We have 11 over 6 and we have the pi rad. Then we'll need to multiply that with 180 degrees divided by pi rad. So meaning to say pi rad here can be cancelled. This is also can be cancelled. Meaning to say 11 over 6 multiplied by 180, that is equivalent to 330 degrees. So this is now the equivalent degree of our radian here. Another example, we have negative pi over 5. So you just need to multiply that one with 180 degrees and we have the pi rad. So again, this is already automatically understood to be having rad here. So meaning to say rad here can be cancelled in this one as well. So we still have pi. We also have pi here, so that can also be cancelled. So we have 180 degrees divided by 5, so that is negative 36 degrees because we have the negative sign here. So that is how easy to convert radians to degrees, degrees to radians. So now let's move on to the trigonometric functions of right angles. We have 6 trigonometric functions if you can recall from your prior subjects or from your previous subjects. We have the sine, we have the cosine, we have the tangent, we have the cosecant, we have the secant, and we have the cotangent. So sine, that is reciprocal with cosecant. Cosine is reciprocal with secant. We have tangent, and its reciprocal is cotangent. So as you can see here, sine is so, or opposite over hypotenuse. If you can remember, we have the so, ka, to, wa, cho, sha, cow. So is for the sine, ka is for the cos, towa is for the tan, cho is for the cosecant. We have the secant, and we have the cotangent. So as you can see, this is paired, this one as well, and this one. So we have here opposite over hypotenuse. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And if tangent is opposite over adjacent, cotangent is adjacent over hypotenuse. So given this right triangle here, if we have the angle here, we all know that the longest side of our triangle is the hypotenuse. And katong line, the other line that touches the angle is our adjacent. Again, if naa diri ang atong angle, it touches the hypotenuse. And again, as we all know, hypotenuse is the largest or longest side of our triangle. So automatically you can see already what is the hypotenuse. And the other side is the other side that touches the angle is the adjacent, and the side that does not touches the angle is the opposite. So that is how we determine asa dito ang adjacent, asa dito ang opposite. I hope that is clear with all of you. Now let's move on to an example. So we have here example, find the 6 trigonometric functions of theta from this right triangle. So we have our angle here. So meaning to say this is our hypotenuse, this is our adjacent, and this is our opposite. So we need to find our sine theta, we need to find the cosine theta, we need to find the tangent theta, and we also need to find the cosecant theta, the secant theta, and the cot or cotangent theta. So sine again is so that is opposite over hypotenuse, and our opposite is 1.2 over our hypotenuse is 1.44. And we also have, again we have the so, ka, to, wa, cho, sha, cow. So we have the cos as adjacent over hypotenuse, so we have 0.80 over hypotenuse, which is 1.44. So let's try to calculate this one. 1.2 divided by 1.44, that is equivalent to 5 over 6. So we have 5 over 6 is our sine theta. And for this one, we have 0.80 divided by 1.44, that is equivalent to 5 over 9. And for this one, our tan theta is opposite over adjacent. So we have opposite over adjacent, which is 1.2 over 0.80. So we have 1.2 divided by 0.80, that is equivalent to 3 halves. So we have 3 halves here. And for the cosecant theta, we have hypotenuse, or the opposite of this one, the opposite of our sine theta. So basically that's just equivalent to 6 over 5. And we have also the reciprocal of our cosine, which is equivalent to secant. So we have 9 over 5. And for the cotangent, that is 2/3. So basically, these are the 6 trigonometric functions that is asked from us to find. We have the sine theta, we have the cosine, we have the tan, the cosecant, secant, and the cotangent. So that is how we look for the trigonometric functions of our theta. Now let's move on to the last discussion of this video. We have the Pythagorean Theorem. So from your high school, even from your elementary days, you are already familiar with the Pythagorean Theorem. So Pythagorean theorem comes in the formula c squared is equivalent to a squared plus b squared. So c is the hypotenuse, a squared and the b squared are the squared of the legs or the two legs of our triangle given this reference triangle here. So given that sine theta is equivalent to 3 over 7, example here, given that sine theta is equivalent to 3 over 7, find all the values of the remaining trigonometric ratios of theta. So if we have this triangle here as our reference triangle, and this is our theta, and we know that sine is opposite over hypotenuse. So meaning to say this one is the opposite and this is the hypotenuse, right? So meaning to say the opposite is here, that is 3, and the hypotenuse is 7. So how can we get the unknown value or the unknown side of our triangle? So we can use this one as our reference, as our formula, and we already know that this is C, this is B, and this is A. So from the formula, we have 7 squared is equivalent to a squared plus 3 squared. Now, to get the value of our a, we just have to 7 squared minus 3 squared is equivalent to a squared. Now, if you try to calculate this one, to get the value of our a, to isolate the value of our a, you just have to square root that both sides, right? To eliminate the squared. So we have a is equivalent to square root of 7 squared minus 3 squared, that is equivalent to 2, and 2 square root of 10. So meaning to say this side here is equivalent to 2 square root of 10. So from that we can already get the trigonometric ratios of our theta. So let's just move this here. We can already have the sine theta is equivalent to opposite over hypotenuse. So we have 3 over 7. Cosine theta is adjacent over hypotenuse. So we have 2 square root of 10 over 7. And we have the tangent theta is equivalent to opposite over adjacent. So we have 3 as our opposite, and our adjacent is 2 square root of 10. So we have 3 and 2 square root of 10. So for the other trigonometric functions like the cosecant theta, so you just have to reciprocate the value of this one. And we also have the secant theta. So we have 7 over 2 square root of 10. And for the cotangent theta, we have 2 square root of 10 all over 3. So this is now the trigonometric functions of our right triangle here. So those were all the discussion for this video. I hope you learned something from this video, and I'll see you on the next upcoming videos. Have a great day, everyone.